color today?
Please, lots of red, whatever it's called. Antique cherry.
That one?
Yes.
Fabulous. Okay. So, A times B to the power of x. Let's talk a little bit about that A and B again. What does the A value represent? No. The y-intercept. For us, we've been talking about it being the y-intercept, but we can also say that it's the initial value because we're getting into real-world scenarios, right? So in a real-world scenario, they won't say, Bobby bought a car and his y-intercept is, right? They'll say that he bought a car for X amount of dollars. Okay, so our y-intercept or our initial value. What about B? The factor. The rate of growth or decay. That growth factor. Very good. So those are our parts of our function. We wrote a little bit yesterday based on tables and things like that, but today we're going to actually look at the scenarios themselves. So if I have example 1, the cost of tuition at a college is $12,000 and is increasing at a rate of 6% per year. What will the cost be after 4 years? So we're not actually going to answer the question for this one, we're just going to write the function because the answer is in the table, right? How much will it cost after 4 years? $15,149. But we need to figure out a way without making a table to get that value. So what's the initial value? 12,000. What do I know about the rate? Is it growth or is it decay? It's growth. You're increasing. So my value should get larger, right? So here's the deal with percentages. When you have a percent, you need to decide, first of all, is it growth or decay? We decided it was growth. You always start with 100%. 100% is our current value, right? 100% of 12,000 is 12,000. Everybody agree with that statement?
Yes.
Okay. But I'm increasing at 6% per year. So I've got to add in my 6%. So what is the value next year as a percent?
106.
106. Okay. And just like you did in 6th and 7th grade, we can't use the actual percent. We're going to turn our percent into a decimal. So 106% is 1.06. And that, my friends, is your B value. Does my process make sense on how that's found?
Yep.
Okay, good. Because if you just found 6%, the value would not increase, it would plummet. All right, so our equation, y equals 12,000 times 1.06 to the power of x. So if I wanted to find the value after 4 years, where does 4 go? X. Good. Okay. So let's look at example 2. Value of a car is $18,000 and is depreciating at a rate of 12% per year. What will the value of the car be after 5 years? What's your initial value? 18,000. Okay. Growth or decay? Decay. So you start off with your current value at 100%, right? And if it's depreciating, what am I going to do with that 12%? subtract it. So how much is what percentage is the new value of the car? 88%. So 88% remains. What's 88% as a decimal? Okay. So now I have everything I need for my function. Y equals 18,000 times 0.88 to the power of x. Good. Why don't y'all use that function and plug it into your calculator and see that it matches up with your table, because that would be a good way for you to check when we're not all working together. So no, just into the normal calculator, 18,000 parentheses 0.88 to the power of 5. Because the question said, what will the value be of the car after 5 years? So you're just checking that your equation works. Did it work? Did you get $9,499? All right, good.
What? I opened my calculator and the first thing I see is just in New York, I really rock. I did it myself.
Okay, let's do one more together. Go all the way to the back. We're going to look at number 5. So number 5 isn't dealing with percents, but number 5 is kind of tricky, because you need to use the table alone to find everything that you need. So we're looking for our A value, our B value, and then we can write our function, right? So f of x equals. But I can't find my A value until I figure out what's happening with the table. So what is my rate of growth or decay? First of all, is it growth or is it decay? It's decay. It's decreasing. So what's my rate of decay? How do I get from 2 to 2 sevenths and 2 sevenths to 2 49ths? Times 1 7. So my B value is 1 7, right? Can I use that to work back to the A? Yeah, because I have my first term, but what I really need is my 0, my initial value. So if I'm multiplying by 1 7th to go down, I multiply by 7 over 1 to go up. So then, good, 14. So A is 14. Do I have everything I need for my function?
Yeah.
Yes. So f of x equals 14 1 7th to the power of x. How do y'all feel about that? So realistically, the only thing that's new, percentages. All right? Giving you a little something new every day. Okay, so your job, you're going to work through example 3, 4, 5, and then do 1 through 4, so that gives you 7 problems to work on. And after you finish that, I made a quizzes that covers units 1 through 3, because that's what we were told would be on your DLA. So it's a lot of questions, but I was trying to put as much in there to give you, because I've had a lot of people asking me, how can I study? Okay, so here's a place for you to see all of those questions in one spot. All right, everybody understand what they need to do? No? Yes? Maybe? Yes. Okay, thank you.